Do you remember what the indefinite integral was? Boys and girls, let's go. F of x plus c. Yeah, we did. I'm just trying to refresh your memory. So, what's the difference between the indefinite integral and the definite integral? Yeah. Definite has bounds, has a and b. Indefinite does not have bounds. So you add a c on the end, and that's that. We covered the first examples. I know that some of them are difficult. You're going to need some time to work on them. My plan right now is that you would have a full work day tomorrow on the assignments I'm going to give to you today as well. But we finished off E and F. Now we get to G, H, I, and J. So we want to evaluate these. A little bit trickier. The algebra is what kind of makes it difficult. Is this indefinite or definite? So what we need to do is we need to find any antiderivative, and after we find it, we plug in 1 and 2, and we subtract the values. So as you look at this right now, any ideas how we go about finding the antiderivative of that? Very good. So Emma's got an idea. She wants to put x to the 1/2 on top, but to the negative 1/2, and then distribute it. Here's another way to think of it. We can rewrite this as the integral from 2 to 1 of 1 over the root of x minus the cubed root of x over the root of x dx. So as long as I divide both parts by it, I'm not reducing, one part and not the other. I'm going to be reducing both parts. So this is okay to do. You don't have to worry about getting your finger cut off. Okay? So in other words, this is the integral. So this is just another way of doing what Emma suggested. 1 over the root of x is the same as x to what power? Negative 1/2. Okay? Minus, how would you reduce the cubed root of x over the square root of x? Yeah, in fact, I'm going to make it x to the 2 over 6 divided by x to the 3 over 6. Because if you were going to divide those terms, what do you have to do? You have to subtract the exponents. If I subtract the exponents, I have to have common denominators. So what's 2/6 minus 3/6? Yeah, I've got more notes. Who else needs it? Oh, sorry guys. Everybody okay with that step? I take the antiderivative, I increase the exponent by 1, and I divide by the new exponent. X to the 1/2 divided by 1/2 minus, what do I get if I increase negative 1/6 by 1? I get x to the 5/6 divided by 5/6. Evaluated from 1 to 2. So divided by the fraction, I can multiply by the reciprocal. So I got 2x to the 1/2 minus 6x to the 5/6 over 5. Evaluated again from 1 to 2. Yep. Exactly. We're just doing more problems like we did before. Just making sure you understand the difference between the indefinite integral and the definite integral right now. Only because it tells us to. Yep, if it tells you to evaluate it, then you're going to evaluate it. We'll do a lot of definite integrals over the course of the next month. Oh, what do you mean evaluate from here to here? I'm sorry. I haven't actually plugged in the numbers yet. I'm just simplifying this part. So, question. People, I can't. There's 3 or 4 questions. I can't hear them. Okay. Yes. Because what you do is you increase the exponent by 1 and you divide by the new exponent. That was our rule for finding an antiderivative for a power. Right? Okay. All right. So let's plug it in. Take out your calculators. Yep, I'm recording. Minus. Everybody's here today. Minus. And then we plug in negative 3. Negative 3 squared is 9 times 2 is 18. And 3 over negative 3 is negative 1. So we evaluate that. We get negative 1 minus 17, negative 18. That's it. Any questions on that problem? Oh, Brooke's not here. Sorry. Brooke, we miss you. We can't wait to see you. All right, let's try a more difficult problem, okay? Ideas for I. What would you do? My guess is right now is that we might have at most 5 people get this problem, that you get this right on the test. Oh, sure, that'll be an idea. So let's look at. It's not. It's not going to help us, but no, I do want to show you what Emma's idea is. She knows that sine squared of theta is equal to 1 minus cosine squared of theta. And so the problem is, though, is that when you plug that in, you end up getting a 2 minus cosine squared. Oh, so you want to plug that in there. Still doesn't work, does it? No, 1 plus sine squared isn't anything. No, 1 minus sine squared is cosine squared. What's that? No, we do know this one. Let's split it up. Let's split it up. Okay, let's go 1 over sine squared. Just like we did up top. Same type of situation. Put sine squared over sine squared. 1. Okay, what's 1 over sine squared? Cosecant squared of theta. Well, that's kind of neat. What do you take the derivative of to get negative cosecant squared? The derivative, so remember this, okay? Remember this. If you have sine of x, the derivative of sine is cosine of x, okay? Derivative cosine of x, negative sine of x. What if we have tangent of x? What's the derivative of tangent? Secant squared of x. So, what do you take the derivative of to get negative cosecant squared? It's cotangent. So the antiderivative here ends up being negative cotangent squared of theta. Now, over break, I did do some work. First of all, well, I remodeled the bathroom. I helped out my grandmother plumbing, did a lot of stuff like that. But then I also sat down and I redid kind of a cheat sheet of notes for you. And I'm going to pull that up here in just a second. I had my wife send me just a little bit ago, but this stuff will be on there for you, and we'll see if that's helpful to you. Yes, Emma? Yes. 1 plus cotangent squared is cosecant squared. So, what's the antiderivative of 1? Or, in this case, theta. So now we got to plug them in. Do you know what the cotangent pi over 4 is? It's 1. So it's going to end up being -1. Plus pi over 4 minus what's the cotangent of 0? So, Zach's no. Zach's question at the beginning was, this is an antiderivative that we don't know how to find. We do know how to find the antiderivative, but the problem is that it's undefined over that interval. So therefore, this is an unbounded one. Okay, you have some discontinuity. If we graphed this 1 plus sine squared over sine squared, you would see a vertical asymptote between 0 and pi over 4, and so therefore we cannot come up with the answer. You can learn more calculus to be able to figure that out, but I just want to show you that example. Let's do one more. What are you going to do here? A product rule is when you take the derivative. We're trying to do the antiderivative. Good, let's do that. What happens? And what is 1 over sine? Cosecant. Do you know the antiderivative of cosecant? If it was squared, you knew it. You know it, but we don't know that yet. Now, it does exist. I'm just trying to show you guys that there's a lot that we can find, but there's so many other ones that we can't find. Here, I'll rattle it off for you right now, okay? Yeah, if it didn't work out, you could do that. That would be fine. Natural. So, this is it. Okay, so you don't know how to do this yet, but I'm just saying that we'll get to a point where I will prove to you that the antiderivative of cosecant theta ends up being the natural log of cosecant theta minus cotangent theta, and you can only take natural logs of positive numbers, so therefore you have to do the absolute value. My point is that we're going to get to that, but right now it's fairly difficult, okay? So what you have is you have the rest of today, and you have all day tomorrow to work on the remainder of this assignment that I give to you. So I don't know how many of you finished up what you're supposed to do at the original part. We're going to go over that today and tomorrow. What did I leave off with for problems? 22? So, you've got a lot of problems here, but I'm giving you a lot of time today and tomorrow to work on them, okay? You've got about 18 minutes right now, then you have all day tomorrow. Now, there is a question, but before I get to that question, let me pull up the sheet that I told you that we would look at real quick.